This is a sponsored talk from Thermo Fisher by Tilly Woodland, Patrick Gordon, and Kelly Arthur from Alstone Medical. So the talk title is Precision Methods and Higher Throughput Workflows using Thermo Scientific Chromeleon 7.3.2 software for VOC Atlas building. So Tilly's a senior analytical R&D scientist here at Alstone, where she's worked for 4 years. She jointly leads a team who are responsible for developing new targeted and untargeted methods within Alstone Medical's research products and services business. So over to you, team, and we look forward to fielding some questions at the end.
Good morning, and thank you for being here today. My name is Tilly Woodland, and I'm a senior R&D scientist and team lead here at Alstone Medical. Our agenda for today is structured to explore 3 key components that are driving our advancements in breath analysis. First, we'll explore the significance of customer studies and the process of building an Atlas library of on-breath VOCs. Next, we'll introduce Alstone's innovative targeted, untargeted method and its role in expanding that Atlas. And finally, we'll discuss the critical software upgrade to Chromeleon 7.3.2 in collaboration with Thermo Scientific and how it addresses the challenges of handling large data sets, all illustrated with practical examples of the improvements achieved. The Breath Biopsy Atlas compiles verified volatile organic compounds, or VOCs, found in the breath of a diverse group of UK adults using breath biopsy Omni technology. The VOC Atlas is an expanding list of VOCs consistently present in the breath of a varied group of healthy individuals and distinct from environmental contamination. This list undergoes continual expansion with compounds added from customer studies and literature reviews in the disease areas of most interest to our customers. It is a reference data set that can be drawn from for all future studies. The VOC Atlas provides multiple benefits as it deepens our understanding of the biological pathways associated with breath VOCs, thereby enhancing our grasp of their behaviour in various populations, leading to improved study designs and biomarker validation. Additionally, it adds in optimizing key aspects of the sampling platform, such as breath collection, sample storage, analysis, and feature extraction, thereby improving overall performance. As part of this continuous growth, new customer studies will feed into Atlas to expand its overall offering. At Alstone Medical, we have created a comfortable collection device and an analytical methodology and workflow aiming to alleviate many of the commonly reported challenges with breath research. This methodology standardizes breath collection to maximize the chance of finding biomarkers. Touching on the sample workflow here, the breath biopsy collection equipment kits are sent to clinical sites, where trained clinicians perform the collection of breath samples and subject data. The samples are then sent to our breath biopsy laboratory for targeted or untargeted analysis on thermal desorption, gas chromatography, mass spectrometry instruments. The TD-GCMS instrumentation is considered our gold standard analytical approach for breath analysis, where VOCs over a wide analyte concentration range are collected via sorbent tubes and analysed via GCMS. The integration of the Q-Exactive Orbitrap into the breath biopsy platform has been an ongoing research and development collaboration with Thermo Scientific to advance the application of breath analysis and address some of the widely accepted challenges within breath analysis. The Orbitrap is well suited to breath analysis, and it can detect VOCs at a range of abundances from high abundance to trace level analytes due to the high dynamic range and flexible scan modes. This is instrumental in breath analysis due to the large disparity in analyte response and concentration. High-resolution accurate mass means ion ratios are stable across chromatographic peaks for improved confirmation of ions for targeted and untargeted analysis. The Chromeleon chromatography data system enables much of the large-scale analysis completed at Alstone Medical. This is facilitated by features such as data integrity, result reporting, and data processing power, which will be discussed in further slides. The key feature of the Orbitrap, which is employed in the building of the Atlas, is high-resolution accurate mass. This significantly enhances compound identification accuracy by distinguishing similar compounds with identical nominal masses but different exact masses a crucial factor for creating a comprehensive and precise compound library. HRAM, as it's known, enriches the library with detailed molecular weight and fragmentation data, making it a valuable resource for future compound identification and analysis. So putting the previous slide into the context of the Atlas building, compounds are added to the Atlas database from an untargeted feature table from a customer study or from the output of literature review. These compounds are analysed using TD-GC Orbitrap for high-resolution analysis, using chemical standards and confirming features from customer studies through retention time matching, retention indexing, and fragmentation patterns. As part of the library building, deconvolution is used to predict the fragment ions against theoretical masses, utilising the accurate mass feature to within 5 ppm. The obtained spectrum is used to expand the breath biopsy library. With this library in place, future studies can have confidence in a more robust compound identification by comparing breath spectra with the in-house library. This allows for precise identification, a comprehensive, accurate mass library, which is a versatile resource for studies, and finally, confirmation in Chromeleon using reference spectra for precise confirmation of compound presence in targeted analysis. This advanced workflow combines high-resolution analysis, accurate mass prediction enabled by the Thermo scientific hardware, and a versatile library to improve breath compound identification, benefiting both untargeted and targeted analysis. So how does this relate to customer studies and our new method? So introducing Alstone's next generation analytical method, which will be employed from next year to improve our global VOC analysis platform and the operational delivery of customer studies. Coined the Targeted Plus method, this method has a dual capability with over 150 target compounds for which the method has been optimized, and in addition, the method is also suitable for untargeted analysis. This method is being developed to have improved analytical capability. This includes better precision of the on-breath targets, compound identification for features outside the target panel, and increased comparability of data within studies. This overall improvement gives better quality data to then grow the Atlas library. Subsequent customer studies will be run on this method, and the results will be fed into the Atlas library. The addition of compounds for specific disease areas or compound classes of interest will prompt the development of further future methods, which will be tailored to different panels. The overall aim is that this generates a suite of methods covering a breadth of potential biomarkers, which can then be made available for future customer studies. The targeted panel for this new method contains over 150 compounds from a range of chemical classes and volatilities, as outlined in the infographic below. These will be analysed in one overall optimised method. With a panel this size, we need software that can process a complex data set in reasonable processing times. And then this will lead me on to the Chromeleon 7.3.2 features that have enabled this in a few slides to come. As mentioned previously, Chromeleon is our chromatography data system. It offers a comprehensive solution for analytical laboratories by seamlessly controlling both TD and GCMS instruments within a single software platform. The streamlined data management approach simplifies and centralizes storage and access of data from multiple instruments through cloud servers. Additionally, Chromeleon enables efficient reporting through customizable templates and automated reporting. Chromeleon ensures traceability through audit trails and records while offering accessibility via its cloud-based network and concurrent user licenses. It implements security with controlled access and defined role permissions. In terms of network protection, data can be accessed even during internet outages. The platform enhances productivity by saving workflows and templates with automated instrument checks safeguarding samples. Users can also benefit from dedicated support through service contracts and compliance for data integrity. As part of implementing Chromeleon as the key data system in our breath biopsy pipeline, we recently upgraded to the next long-term supported version, 7.3.2. The upgrade has introduced new advantages harnessed in the development of our new method and the expansion of Atlas. Notably, The expanded target panel for the new method, comprising of around 150 compounds, had previously posed processing speed challenges. In response to customer feedback, adaptations to database schemes and data processing services for mass spec data have been implemented, significantly enhancing software speeds for processing and reporting, and ultimately improving the overall efficiency of the system. Some initial testing on a demo version of 7.3.2 showcases the improvements made by the update. During a test of the software, a list of actions were undertaken as a comparison of task durations for both versions. This worked example was conducted on method development data, which includes the 150 plus components. Previously, the speeds were difficult to work with, at around 30 seconds for a single click when navigating the data studio, which resulted in sequence reviews taking multiple days per sequence. The enhancements in navigation speed now result in remarkable time savings, making tasks roughly 20 times faster, which has a marked effect on study throughput. To summarise this talk, our customer studies are instrumental in providing us with the data to be able to build our breath biopsy atlas. Our new targeted, untargeted method, along with the Chromeleon update, which allows us to process our data more efficiently, will bring us even better quality data with improved precision and improved compound identification. This in turn will help us build a more comprehensive atlas which can be used throughout customer studies in our future. Huge thank you to the teams involved in these projects, the Atlas team, the method development group, and those who implemented the Chromeleon rollout. For more information on the GCQ Exactive or Chromeleon, please contact Dominic Roberts. And if you'd like more information about the breath biopsy services or anything else we've talked about today, please contact using the email below. Our team are happy to follow up, but of course I'll be happy to answer any questions you might have now.
So one quick one just related to the dynamic range of the instrument itself. So Mike mentioned in the last talk, breath obviously is a very broad dynamic range. I was wondering if you could comment on the suitability of the instruments given the challenges that are at breath as a sample matrix.
Yeah, so as mentioned in the PowerPoint, obviously breath, the compounds on breath cover a wide range of concentrations, and the Orbitrap is very well suited to that. So it can go down, I think within our stone we've seen to PPT, but we also see, like mentioned in the previous PowerPoint, that we have that disparity where some compounds will be really overexpressed. And the dynamic range allows us to see both ends of the spectrum.
You mentioned the idea of building out the atlas over time using other analytical approaches, different columns and the like. I was wondering if you could comment on some of the classes of compounds and applications that the team are kind of building out at the moment. I know microbiome and short chain fatty acids are particularly interesting at the moment.
Yeah, so that will be the next panel of compounds that we look at, the short chain fatty acids and related compounds, aldehydes. The panel we're currently working on covers a wider range that isn't necessarily specific to any disease areas. But the short chain fatty acids have come up recently in a lot of studies related to the microbiome. And it's one of the areas that customers are most interested in. So that will be forming kind of one of those next panels. And like you say, it might be on a different column, slightly different method, but it's kind of the next step.
Great. One question here. What's the difference between the VOC Atlas and other mass spec libraries mentioned previously?
Yeah, so I think the other library mentioned previously is the HRAM, the High Resolution Accurate Mass Library. They are separate entities. The HRAM gives us the ID of the compound based on spectra from fragmentation, and then the Atlas links those IDs to feature tables to the context in which the sample has been, the kind of disease area that's been seen. This helps us for interpretation of our feature tables. So for example, you would collect your chromatogram, the TIC, the HRAM would help you to build the feature table, and then the Atlas would help you to clinically interpret the feature table to provide context for that sample. And maybe in the future, we'd like to link the two. They are separate, but they're complementary tools to reach the endpoint.
Brilliant, thank you. There's one last question here that I might be able to help answer. It's related to the presence of indole in the VOC Atlas, and the question here is about getting access to it. So obviously the VOC Atlas is something that is integrated alongside all the customer studies that we do. But if there's specific compounds that anyone is interested in the research community, do let us know. We're very happy to share what we found in the Atlas. So an example of indole is very abundant on breath, so we're happy to share the ranges that we find as well. So that's a kind of open offer to anyone in the community that does have those types of questions. We'll be looking at ways to try and make that database more broadly accessible as well. But in the meantime, please feel free just to kind of message us directly for specific requests for compounds. And as I said, we're very happy to share all the raw data with you there. Excellent. Thank you so much for that, Tilly. Really appreciate the time today. And thanks for all your fantastic work.